Hello everyone, my name is Nageer, and I'm going to talk to you about how you can leverage IBM Cloud Object Storage to improve your CDN performance and storage cost efficiencies. So Nageer, I'm a solution leader for M&E in the Cloud Object Storage team, and Cloud Object Storage is formerly known as CleverSafe, and I'll go into that. So I've got 20 minutes, so I could talk about my background in 20 minutes alone, but I'm not going to do that. Here's a quick agenda to try to get us through this subject. I'm going to introduce to you guys what the IBM Cloud Video Services are and how it was formed. I think that provides a really good foundation of what object storage is and how you can leverage it. And then we're going to talk about why cloud object storage from a cost, performance, growth perspective. And then I'm going to focus specifically on two specific use cases, cloud DVR, over-the-top content repositories, and go into some specific use cases. And if time permits, we'll look under the covers and how the technology works. But I invite you all to come over to our booth. If you find this interesting, I'd love to talk to you guys to death about this technology, all right? So here we go. So what is the IBM Video Cloud Service Unit? So it's a unit formed from the acquisition of some really key technologies out there. Clearleap, I believe they have some presence out there right now, Ustream, Aspera, and CleverSafe. These are some acquisitions that IBM has done over the years to try to build their video ecosystem of services. What's really missing on this right now is the data center, software, Bluemix, and how that integrates, right? So if you put all of this together at the foundation, you've got IBM Cloud Object Storage, which is from a layman's perspective or from a competitive perspective, it's what an Amazon S3 bucket is. And that's why IBM really looked at us to help grow their cloud presence. We are an S3 object storage repository. We started on-prem, but there is nothing stopping us from being enabled in the cloud. So we're the foundation. You have Ustream that is online broadcast and streaming service, and clearly end-to-end video streaming services to manage and monetize multi-screen experiences. And then Aspera, right? They're the high-speed video transports that look at your origin stores, whether they're in object storage or other, and be able to provide a really fast transport to your delivery services. And then obviously the data centers that these reside in. So when we're talking about, cloud services, we're talking about IBM Cloud. And software, Bluemix, we're talking about 42 data centers worldwide and continuing to grow, all right? So this is what the architecture of the services look like. At the foundation, you have the software data centers, CleverSafe, Cloud Object Storage. You have your ingest services provided by Ustream, Clearleap, Aspera, the workflow. And depending on your use case, right, you could have Ustream providing some of those use workloads, and you can have Clearleap doing that for the distribution. And then when you tie this into what IBM is really trying to do is focus on cloud and analytics with Watson, and the services API and how you tie that all in. That's IBM's vision, right? Is to be able to tie video, whether you're talking about video analytics, speech to text, machine learning, all of that things that Watson does. You have that repository that lives in object. It's storing all your video content. Now you can do some further analysis, Watson analysis, and be able to get more value out of your content. So why object storage? So I want you guys to keep that little note there. I always like to answer that. It's about storage infrastructure economics, right? So we are seeing unprecedented growth in enterprises today. What's really driving that growth? It's smartphones. You look at it, traditionally we come from an environment, if you're a storage person, you got tier 1, tier 2, tier 3 type storage. It's really changed. I look at it two types of storage, structured data and unstructured data. And the big hockey curve is driven by this unstructured data, smartphones, Internet of Things, telemetrics, audio, video, text, blogs. That's all driving the growth. We're seeing a 60 to 80% year-over-year growth. And the challenge is, can our existing storage infrastructures support that? Our traditional file and block, right? We have, they say, 30x growth in this by 2020. Video, 4K videos everywhere. This is an interesting statistic. Every 1 second, 1 million minutes of video traverses the internet. And that's all driven by our smart devices, right? So I think we're under a challenge from storage infrastructure to have a division, a strategy to be able to manage this growth, right? So video resolution has a direct impact on file asset size. You're looking at 4K, 5K, 6K. What's next? All of these devices are being able to support this kind of resolution. Here's a deeper look at how 4K content is driving archive storage. This is just an impact on storage infrastructure, right? I really like showing this slide. We can't keep this level of growth with traditional storage systems. Remember my term, infrastructure storage informatics. So traditionally, how are we managing this kind of growth? We're doing file-based storage, hierarchical storage, directories, directory file storage. It sort of mimics human behavior. We're used to folders and files and folders and files. That has a breakdown when we start scaling. It can't scale to the petabyte growth levels that we're seeing. Data's exploding, and yes, you can continue to do it that way, but does it make sense? If I were to analyze your existing storage infrastructure and take a look at the content you're storing there, the majority of it that's on file storage, expensive spinning disk, hasn't been accessed in the last 60 to 90 days. Why would you continue to do that? So and that kind of storage infrastructure is really designed for a LAN, right? And there's a point where the number of files and directories of a single namespace starts to affect performance. And you could spin up more storage arrays, more mount points. But it becomes a management nightmare to support that kind of growth. This is where the economics come into play. So with object storage, you have a flat namespace, right? Key, value, key, value. Flat namespace, very easy to grow, very scalable, simple to access protocols. It uses a REST API. The predominant ones out there are S3, OpenStack. CleverSafe had their own proprietary one. We are a proponent of S3 going forward. And this is really designed for web scale growth and economics. So this is really the object is designed for data storage of today and the future. So for the next generation, it must scale, it must be more efficient, must always be available. We're looking at geographic kind of accessibility with the world becoming larger, we're all one economy these days. We must be able to have data integrity and security. And when we look at our legacy systems, they can't scale to that level. And when you're looking at protecting that data, they're relying on very old technologies that take a very long time to recover. RAID 6, however, you want to rebuild a 20 terabyte drive, whether it's a 74K or 15K RPM, takes days to recover that. You need an infrastructure that gets rid of that. So our solution, a lot of the object solutions, are the way you want to be able to do that. Here's a key quote from one of our customers. As a media and television company, we have a huge amount of unstructured data and we needed a storage platform that enabled us to support data and scale so we can meet the needs of tomorrow. CleverSafe, IBM Cloud Object Storage, worked with us to get it right. So I've got some really good use cases of how we've helped a lot of other customers do this. Love to talk to you guys, but this is solid technology. So what is IBM Cloud Object Storage? So a little bit about us. We're not a new company. We've been founded, we were founded in 2004 in Chicago, shipping product for a while. We're a software-defined solution. So we run on commodity x86 hardware. We certify different platforms. So I'd like to say we're software, hardware aware. So on our specific nodes, we want to know what kind of hardware we're on, so we go through a certification product. We have over 400 patents awarded, more coming, rated high on all of the Gartner's lists as an object storage player. We have multiple petabytes in production. Customers that are using this and multiple exabytes, I should say, in production. Some very big customers. I can tell you what those are. Come visit our booth. Again, this is Gartner and IDC showing our market leadership. So again, we were a good acquisition for IBM to grow their object storage platform in the cloud. But we are still an on-prem play, and that's one of our differentiators. It's an ideal for cloud workloads with unstructured data. Massively scalable, simple to manage, technology that uses logical constructs, and I'll get into a little bit more detail. So if you do a side-by-side comparison here between file storage and object storage, you can see where we excel, right? Store millions of files, hundreds of billions. I mean, the scaling of our object storage platform is literally web scale, infinite. I have a specific customer, I'll quote Shutterfly, right? They were deployed originally on a NAS-type infrastructure, had 15 administrators to continue to grow that platform to support their growth, and their growth was exponential. Everyone was putting their pictures up there. They went on CleverSafe, continued to deploy up to an exabyte and beyond, went down to 3 admins, because it was that simple to manage that kind of data. So that gets that infrastructure cost and economics I was talking about earlier. So I'd like to get into a little bit of some of the use cases that object plays well. We talked about unstructured data and what that means, but here are the specific use cases that we support across the enterprise. We fit well with digital asset management solutions. We work as a store for production archive storage, disaster recovery services, user-generated content websites. That's a Shuttercase use case. Video surveillance, this is a growing area. The 3 areas that I highlighted here have more applicability for what the purpose of this show is. Cloud DVR for cable service providers, linear and video streaming, video playout, and CDN content origin stores. We also are working really well for Hadoop repository to do analytics and Watson type of analytics as well. So here are those same use case areas broken down into segments, and the partners, or the ecosystem partners that we work with to support solutions. Now I can tell you this, all of these, so legacy applications, when we talk about file-based protocols, we're talking NFS, CIFS, or block, some kind of block protocol. The majority of these players here are talking native S3 or are across the transitioning their application stacks to talk native S3. So the ship has sailed, right? All of these providers are looking at the benefits of REST API and S3 protocol and are going towards an object storage platform because of the benefits I just laid out, right? So what we're going to probably be focusing on is video production archive use cases and MAM object stores for this specific use cases I've got coming up. Here's just a couple of our little logo slide here of where some of the customers we've worked with solutions. The M&E space is the area that I work in. Now here's a closer look at a cloud DVR real use case. The customer that we have here, I'm not sure if I can reference it, but it's a big broadcaster. They got a peacock for a logo, whatever. This is somewhat a specialized use case for cable operators who want to provide cloud-based DVR services. I've included it in this deck because I wanted to show you guys the power and flexibility of the IBM Cloud Object Storage. This client services millions of subscribers in multiple regions across North America. Every subscriber chooses a show they want to record, right? So you guys know how DVRs work. So this is a network-based DVR using cloud object storage as your 100 megabytes or however much you got out there, right? So in large markets, there are potentially millions of subscribers recording the same show. We worked with this provider, and so the key component of this solution is being able to work with the supported recorders. And there are a handful of vendors out there: Cisco, Aris, Rio, Ericsson, Imagine Communicated. We're all certified, our technology is certified to work with these recorders. So they are using Object Repository to be able to support recording of these subscriber shows. So we can talk in more detail on that. So the key features that we provided is a feature called Slice Fan Out, and you'll understand what that means more when I talk about our technology. But we create multiple unique copies with a single write. So for each subscriber that wants to write that, we actually fan out a write to our object storage, depending on the segment size, how much they want to record. Unique combination of copies, Docker Accessor, that's like a little technical term, but that we will take one of our heads and put it in a Docker container. We do geo-dispersion, where all the data everywhere immediately available. The footprint reduction with no replication. We don't do replication, we do geo-dispersion. I'll get into that, what that means for you. Scalable, a single namespace. This is the advantage of object storage versus using a file-based block protocol. And it's a multi-API layer. We write Swift, we read S3, we maintain naming conventions, right? So here's Here's an example of using object storage for CDN. You've got a dual write that takes the content coming in, we write to an origin store that's based on CleverSafe for cloud object storage. The long tail content goes to a transcoding farm. That transcoding then goes to a CDN and your subscribers. So we are, in that specific scenario, the origin store for the content coming in. So for CDN storage and over-the-top streaming applications, here's how object storage fits into that. It's the distribution origin storage, the long tail content storage. We also support long-term mezzanine archive storage, or we can use archive content package storage. And I'll go into a little bit more detail what most of those mean. So for an origin store, we use HTTP GETs for delivery. So this is the REST API. And when we look at all of the application ecosystem, the vendors that are supporting media asset management system, content delivery systems, all their apps are changing to a REST API, and they're supporting this kind of protocol. So as an origin store, we natively stream from object because we're using a REST HTTP protocol. We could provide over 1,000 terabytes of storage. We can go even further. And we provide multiple high bandwidth connections. So multiple 10 gigabit. We're at 40 gigabit on some of our newer hardware systems. For long tail content storage, we use commodity hardware. Cost per terabyte is lower than other storage options. We use object for less frequently accessed content. So again, when we take a look at our production workflow, you're going to need the high-speed NAS and the flash to do your editing and delivery. Well, once you're done, you're going to put it back into an object repository. And again, when we talk about this growth to support the high resolution, do you want to continue to put that archive content on a very expensive storage? Probably not. So the same applies to deep mezzanine content storage. Cost per terabyte is lower. The ability to archive a vast array of content for faster recovery or re-encoding. So I have a lot of customers in the studios that are currently using that tape infrastructure to do their deep archive, and they retrieve it and then transcode it, re-release it in another format, and then put it back. Now, we all know how tape works, and it's great, it has its purpose, but if you had a deep archive that was working on a tape infrastructure and you needed content back, tapes go bad, versus having a object storage solution based on spinning disk, you can see how you get faster return and latency on getting your objects back into your workflow a lot faster. And the same thing applies to finished packaged good content storage. The cost per terabyte's lower, very valuable. So multiple language support. So again, this is the repository for your finished packaged good. Here's an example of how we would do that. So what you're seeing here with this, the origin store and each one of those going to edge servers, you can imagine using Aspera to increase the transport between these nodes, right? So we all work with our partners. We're doing okay. Let me blow through this real quick. So this is looking under the hoods. I'm getting close to getting the hook here. But we have 3 components of our solution: the manager, the accessor, and the slice stores. So you can imagine the manager out of band. The accessor is our heads, if you're used to traditional storage, and our slice store of our storage nodes. We're supported on certified hardware from IBM, Cisco, Hewlett-Packard, and there's a slew of others. We're software-defined, hardware-aware. So what else have we got? So this is a quick slide, okay? So how we do our technology versus our vendors is we have inherent information dispersal architecture. So we use erasure coding, forward error correction. We've patented. We do it differently. So content comes in. We then add extra data to that content to be able to recreate it from a subset of that content. We give you these 2 parameters called a width, which is the overall threshold of the payload width. And then that's dynamic, and then we have a read threshold. So it says, if I were to slice it out this wide, 12 in this case, and I have a read threshold that says I only need a subset of that to recreate it, which is forward error correction, erasure coding, I could sustain a level of loss without losing bit. So this is a 12 wide. I can say my read is 7. I only need 7 slices to return bit perfect copy. That means I could, if I were to deploy this over a geodispersed, I could lose an entire site and still give you bit perfect copy. So I'm going to stop there. And please come and see us at our booth, and I can go into more detail. I have a lot more slides here.
A little applause for it. Naz, thank you so much.